Throughout human history, we've gazed at the starlit sky and wondered, why is there something rather than nothing? It's a question that has echoed through the halls of philosophy, religion, and science for millennia. Where did this vast, intricate universe, teeming with galaxies, stars, and planets, come from? Some find solace in the idea of a divine creator, a God who willed the universe into existence. Others turn to the language of science, seeking answers in the laws of physics and the echoes of the Big Bang. But the ultimate origin of the universe, the very first cause, remains one of the most profound and elusive mysteries we face. Yet, even in the absence of a definitive answer, the pursuit of understanding is a journey worth taking. By exploring the cosmos and unraveling its secrets, we gain a deeper appreciation for the intricate beauty and awe-inspiring scale of the universe we inhabit. In this quest for knowledge, we discover our place within the grand cosmic narrative. At the heart of this cosmic mystery lies a fundamental concept: energy. Energy is the lifeblood of the universe, the driving force behind every process, from the birth of stars to the rustling of leaves in the wind. It's the invisible hand that sculpts galaxies, ignites suns, and sets planets in motion. In the vast cosmic tapestry, energy takes on countless forms. It surges through the cosmos as light and heat, crackles within the cores of stars as nuclear fusion, and binds galaxies together through the invisible grip of gravity. It's the very essence of motion, change, and transformation. Without energy, the universe would be a static, lifeless void. No stars would shine, no planets would orbit, and life itself would be impossible. It's the fundamental ingredient, the essential building block from which all else is constructed. If energy is the lifeblood of the universe, then the spark represents its very genesis, the moment of creation. This spark, often referred to in scientific circles as the Big Bang, wasn't an explosion in the traditional sense. It wasn't a detonation into pre-existing space. Instead, imagine an infinitely small, infinitely dense point containing all the energy and potential of the universe we know today. Then, in a fraction of a second, this point began to expand, an expansion that continues to this very day. Space itself was created in that instant, stretching and unfolding as the universe rapidly cooled and evolved. From this primordial soup of energy, the fundamental forces of nature emerged. Particles formed, coalesced, and eventually gave rise to the first stars and galaxies. The universe, once a sea of undifferentiated energy, began to take on structure and complexity. Section 4. A universe in motion. Expansion and the illusion of endless energy. One of the most astonishing discoveries of modern cosmology is that the universe isn't static. It's not a fixed stage upon which the cosmic drama unfolds. Instead, it's a dynamic, ever-evolving entity, constantly expanding in all directions. Imagine a balloon with dots drawn on its surface. As you inflate the balloon, the dots move further apart, not because they're moving across the surface, but because the surface itself is expanding. Similarly, galaxies are receding from one another, not because they're flying through space, but because the very fabric of space is stretching. This expansion has profound implications for our understanding of energy. It suggests that the total amount of energy in the universe may not be constant, as classical physics once assumed. If space itself is being created, then it stands to reason that new energy might be coming into existence as well. Section 5. A cosmic balancing act. Conservation amidst creation. This notion of new energy creation seems to contradict one of the fundamental laws of physics, the law of conservation of energy. This law states that energy cannot be created or destroyed, only transformed from one form to another. It's a cornerstone of our understanding of the physical world. So how do we reconcile the expansion of the universe with the conservation of energy? One possibility is that the new energy being created is offset by a corresponding increase in negative gravitational energy. Gravity, after all, is a force of attraction, and its potential energy is negative. As the universe expands, the distances between objects increase, and so does the gravitational potential energy. This increase in negative energy could, in theory, balance out the positive energy being created, preserving the overall energy balance of the cosmos. Section 6. Humanity's Energy Dilemma. A looming crisis? As we delve deeper into the mysteries of cosmic energy, a sobering question arises. What if our insatiable appetite for energy eventually outstrips the universe's ability to provide? Humanity's reliance on energy has grown exponentially since the Industrial Revolution. We power our homes, fuel our transportation, and drive our industries with an ever-increasing thirst for power. But what happens if we reach a point where our energy consumption exceeds the rate at which the universe can generate new energy? Could we potentially tip the cosmic scales, upsetting the delicate energy balance that governs the cosmos? It's a question that highlights the interconnectedness of our existence with the grand cosmic scheme. Our actions, no matter how seemingly insignificant, have the potential to ripple through the fabric of the universe.